MOSFET as a switch. This is a diode D1. This is capacitor C1, and this is the load. So input is a constant DC supply. When this switch is in on state, if we apply the gate signal to this MOSFET, then this MOSFET is in on state. Okay, so means at that time this switch is closed and current flows through DC supply, inductor L1 and switch. In this fashion, your current is flowing. So during this time period, your inductor start storing energy. Inductor start storing energy. एनर्जी इंडक्टर में कैसा चार्ज होगा, स्टोर होंगे. हैंड साइड इज पॉजिटिव, राइट हैंड साइड इज नेगेटिव. When the energy stored in the inductor is equal to the supply energy, or when the voltage induced at the inductor is equal to the supply voltage, then when this inductor voltage is equal to the supply voltage, okay, and its polarity at the energy stored in the inductor is such that left hand side is positive, right hand side is negative. This is a DC input. Upper terminal is positive, this is negative. So if the positive is connected, both voltages are the same. So net voltage becomes 0. If net voltage becomes 0, so this switch goes into the off state. This switch goes into the off state. Once this switch goes into the off state, then all of you know the property of the inductor. It produces the back EMF. It produces the back EMF. Back EMF produced means it will change its polarity. Now left hand side polarity becomes negative and right hand side polarity will become positive. Here this positive is connected to anode of D1. This positive is connected to anode of D1. So your diode D1 is in forward bias. Diode D1 is a forward bias. So this capacitor start charging through DC supply, then energy stored at the inductor through diode and through this. In here, voltage across the inductor is such that its polarity is left hand side negative, it is a positive, and its magnitude is L di by dt. So this plus this voltage. The capacitor will charge up to this plus this voltage. Means ideally this is Vs, VDC. Inductor will be charged up to VDC. If the resistance of the inductor is very less, ideally it is 0, then the voltage across the inductor is nearly equal to the maximum supply voltage. Okay, so this VDC plus this VDC, so your capacitor will be charged up to plus twice VDC. And current is flowing through this fashion, through DC supply, through inductor, through diode D1, through capacitor. कैपेसिटर में करंट फ्लो होगा ऊपर से नीचे, तो ऊपर का पोलैरिटी becomes positive and lower terminal becomes negative. So once capacitor will be charged up to this Vs plus this Vs, that is equal to twice Vs. So your this diode D1 becomes a reverse bias. This diode D1 becomes a reverse bias. Okay. So this is a plus, this is minus. Then capacitor discharge through the load. Capacitor discharge through the load. So in this fashion, you will get the output voltage. average output voltage is more than the supply voltage VDC. So that's why it is called a step-up chopper. If the output is greater than the input, so output voltage is greater than input voltage, so it will be acts as a step-up. Okay, step-up chopper. Okay, here. During first step, this is positive, this is negative. So your current is flowing through switch. This. So energy starts storing in the inductor is such that this is a positive, this is a negative. Okay. Once energy stored in the inductor is equal to the supply. Okay. So at that time, this switch is in a off state. ये switch off हो जाएगा. So property of the inductor, it produce the back EMF. Back EMF produce करेगा, so its polarity will be changed. Now it becomes negative. This becomes a positive. So this positive is connected to anode of diode. So this diode will be acts as a forward bias. Diode will be acts as a forward bias. Now capacitors start charging through this inductor, through diode, and through this. And capacitor will be charged. See the polarity. Supply voltage polarity. This is a plus minus. Back EMF. This is minus plus. Dissimilar polarity are connected. If the dissimilar polarity are connected, then there is a addition of the voltages. So your capacitor will be charged up to this VDS plus this VLDC. VL voltage across the inductor. That is equal to L into di by dt. Okay. So once capacitor will be charged up to this VDC plus L into di by dt, at that time its polarity is this is a plus, this is minus. So at that time potential is greater than the anode potential. क्योंकि क्या हुआ है, इसका इंडक्टर का एनर्जी रिलीज हुआ है, तो इंडक्टर का एनर्जी कम हुआ है. इंडक्टर का एनर्जी कम हुआ है, किधर ट्रांसफर हुआ है, इन कैपेसिटर. So means anode side voltage of the diode, now it is less than the cathode side voltage of the diode. So cathode voltage is greater than the anode voltage, so your diode goes into the off state. So it will be acts as open circuit. So it will be acts as a open circuit. So at that time, your DC output voltage is Vin plus VL, where VL is equal to L into di by dt. So means your output voltage is greater than the input voltage. Output voltage is greater than the input voltage. So this is the operation of the boost converter. Okay. I have found one good video on this boost inverter. Are you seen? I am going to share one video to you. Are you seen my screen?
Yes, sir.
Okay. I am going to run this video. Please listen carefully. If you have any doubt, you can ask in between.
Episode 1. Today, we're going to have a look at this amazing circuit, which allows us to step up a lower voltage into a higher voltage with quite simple circuitry. You can see here there is a 9-volt power supply, but on the output of the circuit I have a voltmeter which is measuring the climbing voltage of this circuit. You can see at the moment I'm getting 60 volts from a 9-volt power supply. This could be a 9-volt battery or any other type of 9-volt DC power supply. Before we go any further, I definitely need to mention, because we are now using higher voltages, you need to make sure that you stay safe. High voltages like this can give you quite a nasty shock, and it takes less than 20 milliamps to stop the human heart. So make sure you stay safe and don't touch any high voltage contacts if you are planning on using any high voltage circuitry. So what we are looking at here is a boost converter, otherwise known as a step-up converter. It is a type of switch mode power supply because it uses a type of switch, in this case it's a transistor, to turn a part of the circuit on and off at a really fast speed. Switching transistors are the main component in any type of switch mode power supply. So let's go ahead and explain how this circuit is taking 9 volts and stepping it up to a much higher voltage. Now this circuit is actually running a lot slower than you would actually see in person, because every circuit cannot process the speed of which everything happens because of lack of operating power. So in this case, as you can see down here, for every 1 second, we are only viewing 300 microseconds of time, which is a very, very tiny portion of a second. So in real life, this voltage would climb almost instantly. So what I'm going to do is actually slow it down even more, and I'm going to stop the circuit and restart it. So we're now starting at 0 volts, and you can see here it climbs very slowly. We're up to 20 volts and closing in on 25 volts. So what's actually happening here? Well, if you watched my previous video, I definitely recommend you go and watch it, because we have an inductor in the circuit here. So make sure you understand inductors, which will definitely help you in understanding how a boost converter works. So I've actually slowed it down a lot more now, because it gives us more time to see what's happening. So now we're looking at 20 microseconds every second. If you've watched the previous video, when you pass current through an inductor, it creates a magnetic field. When you change the voltage passing through an inductor, the inductor's magnetic field will start to collapse, and thus inducing current through the inductor as it creates a high voltage spike as the magnetic field collapses. So this circuit is taking advantage of that very property of an inductor to step up voltage. So here we have this MOSFET transistor. So just imagine this as a normal on-off switch, but we can switch it on and off very, very fast. We can switch it on and off hundreds and thousands of times a second. So I'm actually electronically controlling this switch to turn it on and off. With this power supply down here, basically I'm supplying power to the gate of this transistor, which just turns the switch on and off every 100 microseconds. When we turn the switch on, current can flow from the 9-volt supply through the inductor, through the switch, and back to the 9-volt power supply. As we turn the switch on, and this current flows through the inductor, a magnetic field builds up in that inductor. Now when we turn the switch off, current can no longer flow from the inductor through to the switch, because the magnetic field in this inductor needs to collapse and induce current through the circuit. Because current can no longer flow through the switch when it's off, as you can see here, the current actually quickly flows through the rest of the circuit, and you can just see glimpses of it. As the switch here is open or off, current quickly shoots through this part of the circuit. We have a capacitor here in parallel. So anytime the current shoots through this part of the circuit, because the collapsing magnetic field of the inductor creates a high voltage spike, it gets pushed through this diode and gets stored into the capacitor. Because there is a diode here, this stops current flowing backwards from the capacitor through to the switch when it's on and back to the power supply. Every time we get a voltage spike from this inductor, this adds to the voltage of the capacitor and therefore steps up the voltage. So the voltage we see on the top of the screen here is actually the voltage of the capacitor. And you can see every time this switch is open or off, we get this voltage spike from the inductor flowing through to the capacitor, as you can see here. Now, as I mentioned before, this would happen very, very quickly, and I'm quite sure this circuit would step up to around 100 volts. Now, just so you understand, As we supply voltage to this inductor, the inductor's polarity on the left side is positive and on the right side is negative. When this switch is off, the polarity of the inductor changes. Instead, negative is now on this side and positive is on this side, which then allows the current to flow to the rest of the circuit because positive is connected to positive. So just to give you an overall view of how it works, let's press play from the start one more time and just watch how it steps up the voltage from 9 volts and how it just keeps climbing. If I could make this run fast enough, it would eventually settle at about 100 volts. Let's press play. So as you can see, this happens very, very fast, and in fact in real life would happen much, much faster. You can see it just steps the voltage up and continues to step that voltage up, and eventually it will settle out, but I can't run it fast enough to show you. So there you go. I hope you've actually learned something about boost converters and how they work. I will put a link in the description if you want to learn a little bit more about them. You can also interact and play with this very circuit. Just follow the link in the description. You need to be on Google Chrome to view it. You can even view or change around the circuit to get a better understanding of its operation. I will be doing a video on actually making a boost converter, so make sure you're subscribed to this channel. Stay safe. Give this video a thumbs up if you...
Hey, are you getting working on the boost converter? Are you understand working on the boost converter? Anybody?
Yes, sir.
Okay. Now we are going to see how we can observe the various waveform of boost converter by using MATLAB Simulink. Okay, so I told you, or I think experiment taken on effect of source inductance on single phase bridge converter. Okay, we have done it on MATLAB Simulink. So already I told you MATLAB Simulink in library of the power system, various component, various sources, okay, various branches are available there. So you have to select each component depending upon your requirement. So first, for the boost converter, we will require the DC source, DC voltage source. Okay, so from that library, sources are there. In sources, all dependent, independent sources, voltage sources, current sources are there. So you have to select the DC source. We will require the DC source. So you have to select that library as a DC source and keep here. This is a DC source. Then in the circuit diagram, we will require the inductor L. So separately, inductor L is not available. Only inductor. So in the property, you have to substitute R is equal to 0 and reactance XC is equal to 1 upon 2 pi FC. Okay. Okay, C is equal to infinity. that will be acts as a short circuit. So you have to select R is equal to 0, C is equal to infinity. So your remaining is only inductor. Remaining is only inductor. So depending upon your requirement, you have to select the value of the inductor. Then inductor is there. Then see the circuit diagram. The circuit diagram. Then there is a switch is there. That is ideal switch. You can use any semiconductor device. So select the semiconductor device. Okay. Okay. For this, will require the pulse generator. Will require the pulse generator. Okay. So select the pulse generator from the library and keep here. Okay. Then here will require the diode. Will require the diode. Here, this is a diode. So from library, you have to select the diode. From library, you have to select the diode. So this is a diode. Okay. Then there is a capacitor. Then there is a capacitor. Okay. So this is a parallel branch. So you have to select the RLC parallel branch. From that, you have to eliminate resistor and inductor. R is equal to 0, L is equal to 0. So remaining branch is remaining is only the capacitor. Remaining is only the capacitor. So you have to select the capacitor. This is capacitor. Now we want to measure the load current. We want to measure the load current. Always current measure in series. Always current measure in a series. So from measurement, in measurement from the library, that is current measurement, voltage measurement, we are going to current measurement. So select the current measurement block and keep here. So this is current. This is a load. Load is a resistive. Again select the RLC load. Then L and C neglect. Only you have to substitute that. To neglect L and C, substitute L is equal to 0. To neglect capacitor C, you have to substitute C is equal to infinity. So your remaining term is only a resistor. Then you have to choose the proper value of the resistor, that is equal to 120 ohm. Yes, taken. So this. Then you have to measure the load voltage. Load voltage always measure across the load. It is across the load. This is across the load. Then you have to connect all the component as your as like your circuit diagram. Okay, here DC source to inductor. The positive of DC source is connected to the inductor. The positive of DC source is connected to the inductor. Positive is connected to the inductor. ठीक है बीच में लाइन खींचो. If the connection is wrong, it shows red dotted line, and if connection is right, then it shows a thick bold line. Okay, so positive is connected to inductor. Then second term of inductor is connected to your switch and anode of diode. Here, switch second terminal is connected to anode of diode and switch or semiconductor device. It is connected to semiconductor device and anode of diode. Then cathode of diode is connected to capacitor C. Then cathode of diode is connected to capacitor C, capacitor. इधर हमें लोड करंट मेजर करना है, so in between this you have to keep the current measurement. Okay, it's ammeter. Current measurement ammeter in between this, in between capacitor and load. Okay. Okay. Then second terminal of ammeter is connected to load resistor R. Load resistor R. Then in between voltage, then you have to measure voltage across the load. To measure the voltage across resistance, so you have to connect the voltmeter is across the load resistor. Is such. और हमें क्या करना है? All these will be observed on CRO. So from the library, you have to take the CRO, and from the properties of CRO, how many inputs are there? One. Okay. This gate pulses. Second, voltage measurement, load voltage, and third, load current. So property you have to select is such that 3:1. Okay. Then here more one you have to select continuous signal. You have to select continuous signal. So always if you want to observe the continuous output, you have to keep this. Already it is available in library of the MATLAB Simulink. Okay, so from there you have to select this block and keep as it is. Don't connect anywhere. Only keep in that. Okay, and this is a multimeter. Okay, multimeter means there is a current measurement as well as a voltage measurement. And this is a pulse generator to operate the to on and off of the semiconductor switch. Okay, then you can run this, you will get the output. Okay, here first capacitor start charge up to Vc plus Vc twice Vc, then it suddenly discharge, then it becomes a call. Charge, then becomes a call. Means each time क्या करते हैं हम स्विच ऑन करते हैं. Okay, जैसा ही switch on होगा, again capacitor will be charged up to twice Vc. That is supply voltage plus voltage in the inductor. Vs plus Vs twice Vs, then it will be discharged through the load resistor. Okay. So this is the your output voltage. स्टार्टिंग में जब कैपेसिटर अप टू फुल्ली चार्ज है ट्वाइस वीएस दिखाएगा. देन कैपेसिटर क्या रजिस्टर का वैल्यू बहुत कम है, तो क्या होगा, सडनली डिस्चार्ज होगा. सडनली डिस्चार्ज, देन इट कीप कांस्टेंट. अगेन ये नेक्स्ट साइकिल में क्या करते हैं हम, स्विच ऑन करते हैं. स्विच ऑन करेंगे तो अगेन इंडक्टर विल स्टार्ट स्टोरिंग एनर्जी और रेजिस्टेंस इज वेरी लेस, तो सडनली इंडक्टर स्टोर द एनर्जी. तो सडनली हम क्या करेंगे, वो स्विच को ऑफ करेंगे. वो वेरी फास्ट होता है, वो स्विचिंग एक्शन इज वेरी वेरी फास्ट. ओके, माइक्रो सेकंड में वो स्विचिंग एक्शन हो जाता है. एट द आउटपुट विल गेट दिस वेवफॉर्म. So next time you have to submit all these 4 experiment. So your first experiment is R triggering. Okay. So in first experiment R triggering and RC triggering, you have to combine R triggering and RC triggering in first experiment. Second experiment is using inductance on single phase bridge rectifier. Okay. Fourth experiment is buck converter. Fifth experiment is
Can you repeat from third?
which काय करा
थर्ड पासून रिपीट करा ना.
परत सांगतो. फर्स्ट experiment, that is a triggering R triggering and RC triggering first experiment. Second experiment is ZT triggering circuit. Okay. Third experiment is effect of source inductance on single phase bridge rectifier. Fourth experiment is buck converter. And fifth experiment is boost converter. Buck converter we have done by using the multisim. Okay. Boost converter we have done by the MATLAB Simulink, or if you want to done by the multisim, you can done by the multisim also. There is no any problem. Okay. And that R triggering we have done on kit. That is a breadboard. If college is started, then we can perform it on a breadboard also. This RC triggering also we can, we are having kit also, and we can perform on a breadboard also. UJT relaxation oscillator. Okay, that you can done by the multisim also, or this R triggering, RC triggering. SCR is not there, so that's why it's difficult by using that. So this also you can done by the multisimals. There is no any problem. But if the college has started, then we'll do it on a breadboard. Okay. So today we are going to perform next is the RC triggering circuit.
Welcome to Power Electronics playlist.
Okay.
I, Professor Hitesh Dolakia, is going to explain you RC in this session. So in this session, I'll explain you resistance, capacitor, circuit, which will trigger SCR by this outlines. So first, I'll discuss the basics which is there in RC triggering of SCR, and then here in this session there are two different RC triggering circuit which I will be going to explain. One is half wave RC triggering of SCR, and second is full wave RC triggering of SCR. And after that, you will see circuits of both of this RC triggering, and then we will see working of it, and then we will see waveform of RC triggering of SCR for both of these cases. So let us begin this session with first agenda, that is basics of RC triggering of SCR. Now see, before I initiate with this session, I'll give you some basic understanding which is there regarding RC triggering of SCR. See, in RC triggering, we connect resistance and capacitance. And when you connect resistor and capacitor, capacitor will get charged via resistor. So whenever capacitor is getting charged via resistor, multiplication of resistance and capacitance, that is time constant of charging of capacitor. And same thing that will happen in discharging. Like see, as if
Okay, I think already all of you know the basic concept of the time constant tau. So tau is equal to RC. If this tau is very large, then this capacitor will take more time to charge. If it is if this time constant is infinity, then capacitor will not be discharged, capacitor will hold the charge. And if this time constant tau is equal to RC is very less, then suddenly capacitor will be charged and suddenly capacitor will be discharged.
Capacitor is getting discharged via resistance R, then that discharging time constant, that is depending on multiplication of resistance and capacitance. So this is what the basic thing which will leads use of